Everybody, this is the homework tutorial for multiplying fractions, worksheet B. Okay, I'm just going to go ahead and start this off looking at number one. Number one is another notorious word problem. However, these aren't so bad. Remember, though, that when you read these, it's very important that you're underlining important numbers and important information. Basically, the whole premise of the problem is that I have a rectangular garden, okay, so I at least give you that information, that has an area. Remember, area is the amount of space a two-dimensional object takes up. An area of 21 square yards. Now, I do ask you to illustrate on this problem. It is actually more important for me to know that you can see it and draw a picture. That's why I've written that as part of the problem and actually the task on the problem, as opposed to just finding a solution. Okay? I've drawn a picture of my garden, so who knows if it really looks like this? It doesn't quite matter. What I have given you is the information that it covers 21 square yards. Now, let's recall that when you find the area of a rectangle, the area of a rectangle is its length times its width. Okay? This can also be expressed as area equals LW or area equals BH, as in base times height. Now, I would challenge you to think already, hey, what could the dimensions of my garden be that would yield an area of 21 square feet in the first place? We haven't even addressed the problem yet. We're just looking at the premise. You know, and so we start to think of, well, what can I take times another number to yield 21? So, in other words, we're starting to look for factors of 21. Now, it might pop into your head to take an easy way out of this and say, well, 1 times 21, okay? Now, I want you to look at this. We could totally make my garden 1 yard by 21 yards. But that would be a long, skinny rectangle, and chances are my garden doesn't really look like that. More than likely, I think most people would chase after or pursue the fact that this is perhaps 3 yards in length and 7 yards in width. This is due to the fact that 3 times 7 is 21 and yards times yards give us square yards. Okay, so hey, we could chase this way. Now, I don't think everybody has to do it this way. And yay, if you want to tune in, do it this way, that's fine. That's why you're tuning into this in the first place. But I'm just here to let you know that there are infinitely many sets of dimensions that would yield an area of 21 square yards. You could actually pursue decimal dimensions, you know, which would be interesting. You could even say that, hey, this is 4 yards by 5.25 yards. Okay, hey, that works. Here's the point, though. The situation in this problem asks for me to expand my garden, and to expand it specifically by half of the original area. Okay, so what I want to do is, and illustrate this, is probably tack on another part of my garden. Now, I didn't have to tack on over there. I could have tacked on down here, for example, and I'll make this part dotted, as in it is not the same thing as this. It's two different situations. But here's the problem that I'm presenting in this problem. I say, first of all, if I'm adding on half of the original area, you need to probably tell me what is half of the original area. We know that of means to multiply, which comes into play later on this worksheet. But I say, okay, well, what is half of 21? Now, here's the neat thing about it. Half of 21 is the same thing as 1/2 times 21. And, of course, we can multiply these, make this a fraction, and plop it over 1. Some of you might be saying, though, hey, to find half of 21, couldn't we just divide it by 2? And that's the interesting property of multiplying with fractions. When you multiply by a fraction, we're actually dividing by this bottom number and multiplying by the top number. Now, remember, anything times 1, okay, that's not going to change it. That's why multiplying by 1/2 is the same as dividing by 2. We are dividing by 2 and then just leaving it the same because of that multiplied by 1. Now, that being said, half of 21, you know, fulfilling this multiplication problem, remember we multiply straight across, we get 21 halves. Now, if I were to simplify this, I say, well, 2 goes into 21 10 times with one of those halves left over. And even as a decimal, we could write it as 10.5. Now, here's basically my ambition. I want to tack on an extra 10.5 yards to the original area. And so you say the original area was 21. The new area, or the addition, will be 10.5. So we say, okay, 10.5 yards plus another 21. Now remember, when you sum with decimals, your decimals have to line up. It gives us a grand total of, we bring the decimal straight down, 31.5 square yards. So here's where we need to stop and think. We say, okay, what two numbers could I multiply to get 31.5 square yards? Well, they're not popping in my head. This is where you're just going to have to kind of play around with it a little bit. But here's what I do know. If I knew one of the dimensions, I could find out what I could take that times to get 31.5 by using a scale factor. So for example, let's say I don't want to mess with this 3. The question here would be, what can I take times 3 to get 31.5 total square yards? Okay. Or maybe I don't want to mess with the 7. You say, what can I take times 7 to get 31.5 square yards? This is an instance where we just work backwards and we have to use division to figure out that unknown factor. Let's say that I do want to leave this as 3 and I wanted to add on an extra however many yards here to expand my area so that it was a total of 31.5 square yards. So I say, okay, 3 times what would give me 31.5 square yards? Writing this as a sentence, it looks like this. But remember, working backwards, let's just take 31.5 divided by 3, and that should yield the new dimension of this side from here out to here. Of course, remember what I said, you don't have to expand this way, you could expand this way. Leave 7 constant, okay, and change this 3 so it expands a little bit more, but you want to have 31.5 square yards. Okay, that being said, moving on this worksheet, number 2, remember, of means multiplying. Here's what we could do. We could just rewrite this as a multiplication problem. And furthermore, we love multiplying by fractions because I'll tell you what, you can just go ahead and do it straight across. No doubt in our minds we're going to have 6/20. Here's what I wanted to pick on, okay? You have to reduce your answers. It's getting very, very old, people not reducing their answers because, look, that's great you can get the right answer, but it's not going to be very useful if we're dealing with very, very large numbers all the time, which tends to happen when you inflate numbers with multiplication. I've been giving you baby fractions. Let's imagine I give you bigger ones. You know, you're going to end up with numerators and denominators that could be, as a matter of fact, astronomical if you had big enough numbers, or even minute if we're talking about things on an atomic scale. And yes, math and science are related. That's why I bring it up. Okay? So let's get used to reducing this. And I'll point out one thing. These are both even. There's a head start for you, okay? But you're looking for common factors between the numerator and the denominator. Now I move on to number 5, and I pick on number 5 for a reason, because we're taking a fraction times a mixed number. Now here's the interesting thing about it. People have a tendency after adding and subtracting fractions to just say, hey, let's multiply the numbers in front, and then we'll multiply the fractions next, and then that's my answer. Unfortunately, when I say 1/2 times 3 and 5/7, that means I need to take 1/2 times 3 and 1/2 times 5/7. This all has to be multiplied, okay? We can't just do it in pieces. So here's what we'll do. Let's find half of 3. Now some of you decimal people are thinking already half of 3 is 1.5. Hey, that's great. You know what? If you want to pursue that and keep that for now, do it. 1.5, keep it in your pocket. We still need to find half of 5/7, and the great thing is that just means multiply. We can multiply straight across. Okay? So half of 5/7 multiplying straight across would yield, looks like, 5/14. What we need to do is take that 5/14 and put it on top of this. So, you know what? It's good practice for you. We still need to add these things together and have a common denominator. Let's go ahead and make this into 14. So we'll take it times 7, scale it up by 7 on top and bottom, rewrite the problem as 1 and 7/14 plus an extra 5/14, yielding a grand total of 1 and 12/14, which, by the way, I think this needs to be simplified. Okay? Now that's one way to think about it, and I did it that way because we're just starting on these things. But honestly, the proper technique here would be to convert this into an improper fraction first. So thinking to ourselves here, we say, all right, 3/3, how many sevenths would that be? Think about this. How many sevenths are in one whole? Well, there are 7 sevenths for every one whole, and we have 3 wholes, so how many total sevenths would that be? Well, let's see. 3 times 7, 21. Plus, we already had 5, so 21 sevenths plus an extra 5 sevenths would be 26 total sevenths. To be very honest with you, here's all I'm doing. I'm saying 3 times 7 is 21. I tack that onto the numerator, so 26 sevenths. Here's the new problem that we look at here. I want half of 26 sevenths. And doing it this way, it becomes much easier to just go ahead and multiply these straight across, and when all is said and done, just simplify, which, by the way, this would yield the same things then. Either approach you take, it's very important that we know how to multiply fractions with mixed numbers, and I'll be very honest with you. To do this, the easiest way to do it is to take all of your mixed numbers and make them into improper fractions, because multiplying fractions is bread and butter. It's straight across, and then we'll just simplify afterwards. And like I said before,